Alright, so what we're going to do is we're going to practice this quiz problem in case you had difficulties. And to add intensity, I'm going to add race music in the background while we do it. So here we go. Alright, so we have Maggie deciding to race a car herself in a quarter mile. Quarter mile is just a straight drag strip, so here we go, quarter mile. 600 meters, 1600 meters is a mile, so that's going to be 400 meters. Alright. When the flag goes down, she takes off at 6 meters per second squared. So that's going to be for the 400 meters. Then it tells us that it's going to take her 600 meters to stop once she crosses the finish line. So once she's at that point there after the 400 meters, it's going to take another 600 meters for her to stop. She doesn't have a car yet. Here we go. Get the car. There we go. Room. Alright. Anyway, so the car is going to travel 400 meters while accelerating like this, and she's going to be stopping, so there's going to have an entirely new acceleration. Right there, when setting up the problem, I should know to set up two different set of variables. One for when she accelerates at 6 meters per second squared, and the other over here for when she accelerates, and I don't know how she is going to accelerate during that time. I just know that she's going to because she's slowing down. So let's fill in what we know. We know she starts from rest. We know the first part of the race takes her 400 meters. We know the last part of the race takes her 600 meters for a total of 100, but I can't put them together because, again, different accelerations. I also know that the final velocity at the second half is going to be 0 because she's going to stop when she's on the very end. As always, as we've been dealing with this spot right here is velocity final, but it's also velocity initial, which means that these right here will translate between the two. So now I just need to find the time for both of them and add them together. Okay? So, let's find the equation that has these four. I know that it's actually displacement is equal to velocity initial times time plus 1/2 a delta t squared. And 0 is going to cancel that whole term there. So I just am left with this. Do some algebra to solve for t ahead of time. So 2 is going to come over to this side. Divided by a, the square root, so I'm going to take, I got a square over there, so I have a square root this side. It's going to be equal to delta t. So plugging in my numbers here, you'll notice how after I set up the equation, I always do plug in exactly the numbers. I put parentheses around this in order to make sure that I don't lose track of any negatives or anything like that, all over acceleration, which is 6 meters per second squared. So after I punch it into the calculator here, I find that the answer is 11.5 seconds. Alright, so that's 11.5 seconds. So I got 11.5 seconds here, and now I need to figure out velocity final, so that'll come over here to be velocity initial. So I can use any equation now with velocity final. The easiest one to use is going to be Vf is equal to Vi plus a delta t. Velocity initial, of course, again will cancel. Acceleration is 6 meters per second squared, and time is 11.5 seconds. That's what I just found. And that will give me velocity final. And calculator tells me that the answer is 69.3 meters per second. So that means that's 69.3 meters per second, and that's 69.3 meters per second. Now that I have three things in my kinematic variables, I can solve for anything else. Now you could solve for acceleration in order to figure out what it is, but you actually don't have to in this case. You can in fact solve straight for time using the equation displacement is equal to velocity initial plus velocity final over 2 times delta t. Again, well, not again, I'm sorry. In this case, velocity initial doesn't cancel, but velocity final does. I need to be careful with that. And now I'm going to do my algebra again. 2 is going to come to the other side, divided by velocity initial is equal to delta t. Plugging my numbers in, that's 2 times 600 in this case, because that changed, divided by my velocity initial, which was that 69.3 meters per second. You'll know meters on top, meters per second on bottom. That will simplify to seconds. And my answer is 17.3 seconds. So that's 17.3 seconds. All I have to do to get my answer, 17.3 seconds, is add these two together. So I'm going to take T1 plus T2 is equal to T total. And it's going to be 11.5 seconds plus 17.3 seconds is equal to time total, which should be equal to, I can do this one in my head, 28.8 seconds. You might have gotten slightly different depending on how you rounded, but that's exactly what the answer is.